Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
It's time again for another episode of the Distributed Data Show. I'm Jeff Carpenter. I am here with Kat Erickson.
Hi, everybody.
Well, it's always good to welcome back familiar faces to the show. And I remember the last time that we had you on, you and I were talking about Docker.
That's right.
So some things have happened since then with our release of official Docker images for DataStax Enterprise. And I think we're seeing some good pickup and adoption of those official images now. You mentioned to me the many millions of downloads of unofficial versions, so hopefully we're starting to put a dent in those metrics and catch up with some official downloads.
We are.
Excellent. So one of the things that I teased our audience on last time that we wanted to talk more about, I think when you start talking about Docker containers, let's face it, I can run a couple Docker containers on my machine or on an instance in some cloud, but really, the whole point is that we begin to be able to do this at scale, right? Which is where orchestration comes in. But I don't want to define it for you because I want to ask you about that. So let me get your definition of what is orchestration technology.
Sure. So I think when a lot of people think of orchestration technologies, they're really just thinking about deploying containers. But it's so much more. I think service discovery is really one of the most valuable features. If you think about deploying web front ends, which is the most popular use of Kubernetes, you could have 5 or 500 depending on your web traffic. And those pods can have a pretty short lifespan. But new pods always need to be able to easily find the backend. So we have these two things that always need to talk, but the ISPs change, their locations change, and it quickly becomes pretty overwhelming to manage. And so to solve this, use services and service discovery. And that's just DNS at a higher level of abstraction. So pods can be created, destroyed, replaced, and as long as you define those applications as services, they can always find each other. But that's just scraping the surface of what's available. As Kubernetes and some of the other players in the space mature, you'll see automated upgrades, failover, and scaling be available for stateful applications like ours, just as they are available for stateless applications today.
Okay, gotcha. Okay, so I have a number of things that I want to follow up on and dig deeper. But let's start with this, just to kind of paint with a broad brush here. Who are the major players in this orchestration space?
Sure. So there are three core technologies here. You have Kubernetes, Mesos, and Swarm. Kubernetes backed by the Kubernetes community, as well as by OpenShift, most of the major clouds, and other players like Pivotal as well, and VMware. And then you have Mesos, which is backed by Mesosphere, offering DCOS. And then you have Swarm, which is offered by Docker as well.
Excellent. So there is a good ecosystem of different supporting technologies. I think they compete on some things. They share some technologies on some others. So this is kind of a fun space to watch right now. So I want to get more on the technical side of things with you now. So you started talking about stateless services, but there are some stateful things that are still out there. So can you help me unpack this a little bit, like running stateful versus stateless applications in an orchestration environment?
So I had mentioned that orchestration technologies like Kubernetes really became popular for stateless applications. And these are applications that respond in the same way for the life of the application. They never store any new information. A GET for a URL will always have the same response. And then you contrast that to stateful apps like Cassandra or like DataStax, and we store all the information that has changed since the application started running. So we are storing new inserts to the database, but we're also tracking who's made requests to the database and changes in the configuration. So essentially, we're maintaining its state.
Gotcha. Okay, so that's one of the things that I really love about service-oriented, and then emergence from that of microservice style architectures, where that's kind of the mantra that you have drummed into you as an architect and a developer, is like, we want to have stateless services. I should be able to call it, and it shouldn't matter if any of my n different instances of that service get called. But then that's all well and good, but then now we get down to the data tier, which is what you're talking about. This is where the actual state has to be stored somewhere. And so it's actually down in the database. And this is where it seems to me like things get a little bit more tricky when you're talking about these environments.
It really is. But the new stack does a survey every year of Kubernetes users and its uses. And one of the interesting responses this year was to the question of, what do you want to orchestrate? And it was front-end web apps, customer-facing applications, and then the very next thing was the database. And that's because the developers that are driving the adoption of these technologies, they don't want to think about the database. They don't want anything to complicate their development. And so once the front ends are orchestrated, it's the database that they want to see available next.
Nice. Okay, so I'm just going to push back because I think it's a little fun here to have these conversations. So one of the things that I know about maintaining a Cassandra cluster is that adding a new node or even taking away nodes can be an expensive operation. So because there's streaming involved, you add a new node, it's going to want to take over a portion of the ring that that exists in terms of how the data is distributed around the cluster. So the other nodes, once this new node comes on and figures out what it's going to take over, the other nodes need to stream the data that kind of belongs to that range. So I don't want to be automatically scaling up my cluster all the time, do I? I mean, that's super expensive. It's going to bring everything to its knees.
Yeah, you're absolutely right. You're not going to use all of the features. I call them the allure of orchestration. You're not going to use everything that orchestrators can do for every technology. You may not want automated failover. So if you have a web front end that fails, sure, deploy me another one right away.
Yeah.
But if you had a Cassandra node that failed, it failed for a reason, and you don't want to rejoin it to the cluster immediately. You need to know what went wrong. So you can use health checks to understand what's going on in your cluster, but you may not react to it like you would with other applications. I'll add that the Cloud Native Foundation, they own the Kubernetes project. They have these guiding principles for cloud native apps, that it has to be containerized, it has to be dynamically managed. So over time, we'd love to see Kubernetes or any of these orchestrators be able to take on any of these very advanced administrative tasks of stateful applications. We're going to have to take those on one at a time as the technology matures.
Okay, well, that makes total sense. Like, as long as we're not saying that we're just going to totally dive into this and expect, the scheduler to understand everything about, when it is that my node should be restarted, or when it's just so messed up that I should give up and replace it with another node. It's, there's a lot of these things that we might not, we will get there eventually, but right off the bat, we may not know enough in order to be able to fully automate all of this, and that's okay.
I agree with you. I think there are a couple of things that are really attractive to database users right now. If you think about Cassandra, you think about linear scalability in adding nodes. But we have some customers that are limited by the amount of data per node. They're already running these very dense nodes. And so what they need the ability to do is scale up. You may need to add extra CPUs and DRAM for things like Black Friday. Orchestration environments and the management of configurations gives you the ability to do that. And not only to do that, but to roll back when that period of peak traffic is over. So there are some really interesting value add propositions that our customers and users want to take advantage of now.
Good. So I like this. I like this flow that we're on now. So tell me a little bit more about how you actually see our customers using Kubernetes in practice.
I really see two major uses. The first is by customers and enterprises offering their own internal cloud environments and platforms as a service. Their internal users want to try out a new use case, They want to be able to quickly stand up a DataStax cluster, 3 to 5 nodes with Op Center for management. And they want to do that without thinking about prereqs, without thinking about where do I have 3 servers sitting around. They just want to quickly get that cluster up and running. And then the second use case is for repeatable deployments of application stacks. And this is what you hit on earlier with the microservices architectures. So they want to build their application stack one time, but then one of the value propositions of Cassandra is the geo-replication. So essentially, they still need to deploy that application stack around the world. And they want to do that in the most uniform and repeatable way that's possible, and that's through an orchestration technology.
Gotcha. Okay, so I just want to be able to stamp that out in multiple data centers and not have to do sort of a custom babysitting it, spinning it up, managing my CloudFormation scripts or whatever every single time.
That's exactly it. And you don't want to have to go through the plumbing of the cloud providers so that your applications can see each other. You need the service discovery piece to be there. You need everything that's going to make all the pieces of your application communicate to work out of the box. That includes your ability to monitor them and see everything that's going on across the application in a single place.
Okay. Gotcha. So this seems like an area where there's a lot of innovation that's continually going on, and I guess it could sort of spin off in any number of different directions led by different companies. But really, who's guiding the maturation of this technology, and how what things are being held in common kind of across companies going forward?
Right. I think there are really 2 driving forces that I see. The first is the user base. The technology is driven to innovate towards users' needs. But then you do have the cloud native foundation that I mentioned earlier that is guiding in terms of design principles. These are the things that a cloud native technology should do. This is, it should be containerized. It should be built around the idea of enabling microservices. It should provide central health checks and the ability to manage itself in some capacity over time. So users drive the demand and some of the innovation, and then the Cloud Native Foundation tries to set the policy and principles.
Okay, and I guess I've been thinking here, maybe I was a little negative before in terms of my concerns about scaling clusters up and down.
No, that should be a concern.
But are there? What I should ask is if there are some possibilities for things that are enabled through orchestration technology that weren't possible before. Does this open up some new possibilities?
Yeah, let's stick with using Kubernetes as the example. Kubernetes has the concept of auto scaling, which is the example that you used. Mm-hmm. But you may deploy using Kubernetes on-prem, or you may deploy using Kubernetes in a cloud. And let's say that you're deploying to Amazon. You may be using their new Kubernetes service, or you may be using what you had developed on-prem. And so the way that you would auto-scale on-prem is going to be different in Amazon because they have their own mechanism for auto-scaling. So you would have to adapt what you're doing to the way it's done in that cloud environment. So while you're looking for uniformity in how you do these things, the underlying infrastructure also drives how you develop that solution. So you could build a trigger that says, if I reach this capacity, I need to add a node. But you don't want to do that, again, like on Black Friday, right?
Right. Or maybe you do, I don't know.
Maybe you do, but hopefully you do it the week before.
Maybe you wanted to do it 3 days earlier or the week before, yeah.
Exactly.
Right on.
So you only want to automate as much as is safe for your use case.
Okay, so you bring up an important point here about the cloud providers and what their offerings are. I think there's been a lot of announcements recently in this space. Do you want to kind of review some of that for us?
Sure. The most recent, and I think what folks find the most exciting, is the Amazon Elastic Kubernetes Container Service. I think it's EKS. Was announced at KubeCon in December. And then you also have Azure that's recently added Kubernetes support. So Azure has Azure Container Service, and that now supports DCOS, Docker Swarm, and now Kubernetes as well. We've seen other announcements recently. You have the partnership with Pivotal and VMware offering, I think it's Kubo, as their Kubernetes service. And so you see, and of course, Google's always been Kubernetes based for Google Container Engine. So you see all the major clouds at this point supporting Kubernetes, and then most of the clouds and platform as a service providers supporting a subset of the others.
Gotcha. So let's wrap things up here. Do you have any final words or any final wisdom to share with us? I know that you're watching this space pretty intently. So where is all this going? What are the things that we should be looking out for in the orchestration technology world?
Yeah, I think we can say it's a really exciting emerging technology. For some things, it is mature and is ready to be used in production.
Mm-hmm.
For other things, it's mature enough to use in production for a subset of the uses, like we hit on earlier, where you may be able to deploy and manage a database, but you may not want to turn over upgrades, failover, and scaling to Kubernetes or an orchestrator at this point. So I think you have to really understand the technology and understand the fit between the solution that you're building and what the orchestrator offers.
Good. Okay. So it sounds like it's not an all or nothing kind of proposition. You can sort of work your way into this gradually and then begin to trust the frameworks with a little bit more of the responsibility as their capabilities mature. Is that fair?
I think that's a very fair statement.
Well, thank you, Kat, for joining us. It's always a pleasure to have you on. And to our listening audience, we just want to thank you once again for watching this show, and we do love to receive your feedback. So we're interested to know, are you using containers? Are you using our DataStax Docker images? Have you tried orchestration frameworks and scaling up your database, managing it through those frameworks? Or any other topics that you're interested in hearing about from us? We would love to hear from you and make this show relevant for you. It's for you, our audience. So we thank you very much and wish you the best until next time.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.